Hello everyone, welcome back. In this section we are going to see our first project, that is find diverse sentences using n-grams. So we are going to see an application of n-grams in a real world project that involves paraphrasing. To start with this, let's connect our Google Colab notebook. And once you're connected, run these two cells. What has happened in the first cell is that we have installed the transformers library and also the sentence piece library for tokenizer. And in this cell, we are downloading the model for paraphrasing. So this is a model that I have developed previously, which is a sentence paraphraser. Essentially, it can take any short sentence and paraphrase it. Paraphrasing means rewriting the same sentence with a different choice of words. So that's what this model does. And you don't need to understand anything with respect to transformers or the paraphrasing models or anything. All you need to do is use this model, and whatever output that we get, which is the paraphrased versions of a given sentence, we are going to rearrange them in the order of highest diversity using n-grams. So no need to know anything about transformers or paraphrasers, etc. Now we are done with downloading of the model. Let's move on to the next section. This is essentially where we use our paraphraser and generate paraphrased versions of a given sentence. So we have this sentence: once a group of frogs was roaming around the forest in search of water. And what we are going to do is use this model that we downloaded. This is the model that I've already pre-trained and kept it on Hugging Face Transformers library, but you can use it directly to generate paraphrase of this sentence. So what's happening in these lines is that we are preparing the text for input to this model. That is, we have paraphrase colon and this sentence, and there is an ending token. None of these are important to us. And then we tokenize this text, and then we extract some input IDs and attention mask. None of these are important for what we are going to do. You just need to understand the input and output. And what we are going to do is pass this text that is tokenized to the model to generate output. And what happens is that we are going to generate 5 different outputs. This is called as text decoding, where we are using beam search, etc. Not directly relevant to us at the moment, but all you need to do is just run this cell. And once you run this cell, you will see the output here, which is essentially you have your original sentence: once a group of frogs was roaming around this forest in search of water. And we are using a concept called as diverse beam search to generate multiple variations of paraphrases to this original sentence. So one paraphrase is: a herd of frogs was wandering around the woods in search of water. A herd of frogs was wandering around the woods in search of water, the same sentence. And a gang of frogs was wandering around the forest in search of water at one time. A herd of frogs was swimming around the woods in search of water. A gang of frogs was roaming around the woods in search of water once more. Nevertheless, we have almost 5 sentences here that are output. Out of them, these 2 are similar. We are going to ignore the similar ones anyways. Now the task that we have at hand is, we have this given sentence and we have these 4 different variations of sentences that are paraphrases to the original sentence. Our goal is to find the most diverse paraphrase. So whichever it is, we need to find the most diverse paraphrase. And why do we need to do that is, Ideally, you want to have the paraphraser convey the same meaning but with a different choice of words. And usually the best paraphraser that we are looking for is one that generates the most diverse sentence, that is using the most variety in choice of words, but still the meaning of the sentence should be preserved. So let's run this cell where we are just storing all the things. So again, we just have our input sentence and we have almost 4 diverse paraphrases that are generated for this input sentence. Now the task for you is order the 4 output sentences, or how many ever output sentences that you have, in the descending order of diversity. What I mean by that is, order these 4 sentences, that is sort these 4 sentences such that the first sentence is the most diverse sentence from the original sentence and the last sentence is the least diverse sentence from the original sentence. And why do we do that is, we can use this algorithm to generate multiple variations of paraphrases, and we can choose the paraphrased sentence that is the most diverse and use it in our final paraphrase. And our goal is to develop an algorithm to compare a given sentence with another sentence and somehow come up with a score. And what's the use case with this? Let's say you have a classification task, that is a sentiment is positive or negative, and assume that you trained a model with 10k sentences. Now you want to evaluate the model on a new data set, test data set of let's say 100 sentences. What you can simply do is, among the 100 sentences, you already know the ground truth, that is the classification sentiment as positive or negative for each of the sentence. Now what you're going to do is run those 100 sentences with your newly trained model and you'll get a different score of ones and zeros, whether the sentence is positive or negative. You can compare the output with your ground truth that you already have. Then you can extract evaluation metrics like accuracy, precision, recall, or F1 score, etc. So at the end of the day, for classification task, evaluation metrics are straightforward and we can understand them. Basically, if there is a label 1 or 0, you know how to evaluate across each other and see how many of them were wrong, how many false positives were there, how many false negatives were there, and get metrics like accuracy, F1 score, precision, recall, all these things. But in the case of text generation, how do you evaluate? For example, let's say you have translation and let's say you have Hindi sentence and you need to translate that to English. And let's say again with 10,000 pairs you have trained a translation system. Now in order to know how good the translation system is, you need to evaluate it again. So again you have, let's say, a new test set of 100 sentences where for each of the sentence you have Hindi sentence and its corresponding translated version in English. What you need to do now is pass the Hindi sentence to the translation model and you get a generated English sentence. Now you need to compare the generated English sentence with your original reference translation that is in English for that corresponding Hindi sentence. So you need to do text to text comparison. So unlike classification, the evaluation metrics for text generation are different because now you need to compare the output text from your model and the ground truth text and come up with some score. So the problem that we have framed here falls into the genre of text generation evaluation metric, and that's why it gets interesting, because we will intuitively come up with some evaluation metric to compare two texts amongst each other, And later you will realize that there are metrics like blue score, BLEU, and rouge, ROUGE, and all these evaluation metrics that are developed for text generation. One word of caution is that none of the text evaluation metrics are perfect. They do not directly correspond to how humans judge two different pieces of text. But nevertheless, if you want to kind of quickly evaluate in a fast manner and see how your model is performing, at least it's a good start. Let's discuss the algorithm of how we are going to solve this, and then please go ahead and try to solve it on your own by writing code. And anyways, in the next section we are going to see the solution to it, but I want you to go and attempt it yourself in code before looking at the solution. So the problem that we have at hand is we have the source sentence and we have 4 different variations, that is the paraphrases of the source sentence, and we want to find the most diverse paraphrase, that is the sentence that is most varied when compared to the original sentence. So our goal is to determine some score when you compare original sentence with each of the individual sentence. Assume that it's kind of some similarity score, and then we need to sort these 4 sentences from least similarity to highest similarity, because least similarity means most diverse from the original sentence. So intuitively speaking, we have seen some kind of comparison metrics already, which is you can tokenize each of the sentence, original sentence and your reference sentence. And we have seen several tokenization algorithms, but for simplicity, let's say you're splitting by spaces and you're just taking one word, that is unigrams. Then all you need to do is how many unigrams from this sentence overlap with the unigrams from the original sentence. In order to normalize this, you can find how many words overlap with the original sentence and divide by the total number of words in this sentence. That gives some kind of similarity score. But by just comparing unigrams, there's a problem, because if you're just comparing unigrams, I could completely randomize these words, which is not even syntactically or grammatically correct. Still you can have the same unigram overlap score. So apart from unigrams, we also need to take n-grams. For example, bigrams or trigrams or 4 grams. So you can take overlapping 4 grams or overlapping trigrams, etc. And similarly, you can get the score by comparing to the original sentence. So you can compare how many unigrams overlap when compared to the original sentence, how many bigrams overlap, how many trigrams overlap, similarly 4 grams overlap. So the first thing is get n-grams from the original sentence and the reference sentence. Now calculate n-gram overlap of the reference sentence when compared to original sentence. For example, let's take unigrams. You will just compare how many individual words are present in the original sentence as well. Let's say 4 words are present from this sentence in the original sentence. Then you can do 4 divided by total number of words that this sentence has, maybe 10, let's say. So 4 divided by 10 is kind of the unigram similarity score when compared to the original sentence. Similarly, you can do it for bigrams, trigrams, 4 grams, where you can find the overlap score and divide by the total number of n-grams for that corresponding n-gram. In order to get the overall similarity score, you can kind of just do the average of n-gram overlap score. That is, you can do 1/4 of 1 gram overlap score and 1/4 of 2 gram overlap score and 1/4 of 3 gram and 1/4 of 4 gram. So since you have 4 different scores, that is unigram, bigram, trigram and 4 gram, you are just averaging out all these scores. So for each sentence, when compared to the original sentence, you can get this average n-gram overlap score, and you can sort them from least score, that is the most diverse, to highest score, that is the least diverse. That's what you can do. And just extending this, there are algorithms like blue score, BLEU, and rouge score, etc. built on top of this, which is n-gram overlap and normalization. So at the end of the day, what you're building here with average n-gram overlap score is kind of some text evaluation metric. And why are text evaluation metrics important? Because let's say you train an algorithm for paraphraser or translation or summarization or image captioning. Every time you need to check whether your model is performing well or not. What you can do is you can keep a test data set, and for each point in the data set, you can generate your text generation output. It could be summary or image captioning, etc. Now you can compare that to the reference ground truth and get a score, and you can average that score across all the points in the data set to kind of get a unified score for the model, how well that model is performing. So this n-gram overlap and comparing them is a very important concept, and there are several evaluation metrics, text generation evaluation metrics like blue score, rouge score, etc. that are built on top of this n-gram overlap score. I want you to realize the practical usage of this, and in the next section we'll see the solution for this.